Good morning, students. This video is the second part of benchmark 3 review, and we will discuss problems numbered from 1 to 35. Before I start explaining the problems, let me review two theorems here. One is remainders theorem and the second one is factor theorem. So already we discussed about these two theorems in the regular classes. So anyway, I gave you two important definitions here. So if a polynomial f of x is divided by x minus a, then the remainder is f of a. So whatever the value of a is over here, just you have to flip the sign to get the remainder. So for example, f of x equals 2x square plus 3x minus 7. If you want to divide this polynomial by x minus 3, what we do? So flip the sign here and we put x equals 3, substitute 2 times 3 square plus 3 times 3 minus 7, which gives you 9 times 2, 18, plus 9 minus 7, which is 20. So this means that if a polynomial is divided by x minus 3, then you got the remainder as 20. So how do you say that? If f of 3 equals 20, this means that flip this sign, right? Flip this sign. That is x minus 3. So your f of x is divided by x minus 3, then your remainder is 20. So the same thing you can express in opposite way, that is by using factor theorem. If this remainder is 0, if f of 3 equals 0, then we say that x minus 3 is a factor for this polynomial. So here the polynomial is given to as j of x, right? So j of x is something. This j of x is divided by, j of minus 7 equals 5. That is given to you. So flip this sign, that is x plus 7, right? And this is your remainder. So this means when j of x is divided by x plus 7, your remainder is 5. So that is your option C, right? Yeah, second question. This is the factor theorem which I explained in the previous problem number 1. So if f of a equals 0, what I told you? Flip this sign, that is x minus a. X minus a, if it is a factor for f of x, then the remainder is 0. So it means here p of k equals 0. Then I can say that x minus k is a factor of p of x. So the option is D here. Alright, this problem is again similar to the problem number 1. There in the problem number 1 there is given j of x there, but here f of 7 equals 2. Again what it says, flip this sign, that is x minus 7. So what is the polynomial? Polynomial is f of x. So f of x is divided by x minus 7, then your remainder is 2, right? This is your remainder. So f of x is divisible by x minus 7. F of x is divisible by x plus 7. F of x is not divisible by So divisible means, okay, if this is yeah, here the remainder is 2, so f of x is not divisible by x minus 7. So the option is C. Okay, which of the following is a factor of the polynomial expression? So if it is a factor, what I told you, the remainder should be 0. So if x minus 1 is a factor, then f of 1 should be 0, right? Or f of 4 should be 0, or f of negative 4 should be 0, or f of negative 1 should be 0. I will pause the video for a minute. Okay, here I think that by substituting x equals negative 4, you get this value as 0. So the option is C. I am not simplifying this one. You do it and see whether you get f of minus 4 equals 0 or not. Okay. Right. Problem number 5. He has given you the synthetic process here. So already we did many problems of this model. So we bring down these 3, and you know the process of doing this one. I explain you this complete everything in summative assessment review. You can watch that video otherwise. Okay, now here, so at the end we got the remainder is 0 here, right? When the remainder is 0, we say that x minus 2, always we have to flip this sign, remember that, right? So x minus 2 is a factor. So which one is the right answer here? X minus 2 is a factor for which polynomial? Okay, so if we have third degree, then you will have number of terms will be 4. So here we have 4 terms here, right? So for example, the highest degree is 3ax cube plus bx square plus cx plus d. So the highest degree is 3. So this is third degree equation, third degree polynomial. So the given polynomial is what? Third degree polynomial. And look at the coefficients here. So 3, 3, negative 8, positive 5, and negative 2. So what do you say here? So it is the option A. So x minus 2 is a factor for this polynomial, right? Okay. Right. This is again using factor theorem. So given you the polynomial here, f of x, polynomial is given, and when this polynomial is divided by x minus k, which of the following values of k would not result in a remainder of 0? So it means the remainder should not be 0. So what is, we have to flip the sign here, right? So x equals k. So let me find out first what is your f of 1 here. So 1 to the exponent 4 plus 2 times 1 cube minus 13 times 1 square minus 14 times 1 plus 24. Find this value and tell me what you get. So everybody got this is 0. Right. Here is asking you to find out for the what values of k. This is the remainder is not 0. So this is not the right option. Now plug in f of x equals -2. So -2 to the exponent 4 plus 2 times -2 cube minus 13 times -2 square minus 14 times -2 plus 24. So if you find out this value, this will be, I think so, you get 0. So this is not a right option. Now you find out for 3 now. So 3 to the exponent 4 plus 2 times 3 cube minus 13 times 3 square minus 14 times 3 plus 24. So this one also you get it as 0. Only for the value of 4 it is not equal to 0. So whatever you get maybe, because the first 3 options are not right means definitely the fourth one is right. So I think so you don't get 0 for when you substitute x equals 4. So what do you say now? So the values of k for which the given polynomial is not equal to 0. It means I can say that the values 1, -2 and 3, these are the roots or the zeros for the given polynomial. Only 4 is, so it means x minus 4 is not a factor. Okay? Alright. Right. Look at the problem number 7. Kim and Sam are asked to use x cube minus 2x square plus 1 to evaluate some function values. Okay. Kim evaluates f of 3 like this. It means he is using reminder's theorem. Right? Sam evaluates f of 5 like this. So he is using synthetic division. So both are right. So which one is right? Both strategies are correct. So problem number 8. Which of the following is the remainder when this polynomial is divided by x plus 2? So again you flip it, x equals -2. So find f of -2, substitute x equals -2 in the polynomial, and whatever you get, that will be your answer. So -2 to the exponent 4 minus 3 times -2 to the exponent 2 plus 5 times -2 minus 6. Yeah, simplify this one. Tell me what do you get. So the answer is -12. Everybody got the same thing? Right. So the answer is B. Right. In problem number 9, he has given you two polynomials here, right? P of x is one polynomial and this is the second version of another polynomial. And okay, so x minus k is a factor or not? What you need to do here, just to plug in first x equals 2 in the given polynomial and check out what you get here. So p of 2 equals 2 cube plus 4 times 2 square minus 7 times 2 minus 10. So you will get this one as 8. Simplify this, you get 0. So this means the second polynomial is nothing but I don't know whether this is x minus 2 times this one gives you the same polynomial or not. So you do one thing. Okay, use synthetic division now. So 1, 4, negative 7, negative 10, and use synthetic division and see whether you get it is 0 or not by substituting x equals 2. So this is 1 times 2 is 2, 4 plus 2 is 6, 6 times 2 is 12, 12 minus 7, that is 5, this is 10, so the remainder is 0. So what is your quotient you get? This is what? X square coefficient, right? This is x coefficient and this is constant. So x square plus 6x minus 5 is your quotient. It means both polynomials are same, and for both polynomials we see that the remainder we got it as 0. One we did it by reminder's theorem, the second one is by synthetic division. So both 1 and 2 statements are right here, so the answer is C. So problem number 10. How many roots does the following polynomial expression will have? So always the number of roots depends upon the degree of the polynomial. So here the degree of the polynomial is 6. Degree is nothing but what? The highest exponent. The highest exponent is 6. So the answer is D. Right, problem number 11. He has given you a polynomial here in factored form, right? So we'll do one thing here. We'll equal each factor to 0. What do you get? X minus a equals 0. So you get x equals a, right? So definitely P of a will be 0. So this is the right option, but we need to pick which is not true. So this is right one, right? Next one, when you plug in x plus b equals 0 means x equals minus b. It means p of minus b equals 0. So this is the wrong one. And p of b equals 0 is also the wrong one. And next, x plus ci equals 0. So x equals minus ci, that is p of ci minus ci equals 0. Anyway, that is not given. And x minus ci equals 0. So x equals ci. So p of ci equals 0, which is not given. Okay, but here if you multiply all x's here, how many x's you have? 1, 2, 3, 4, 5. So that is the fifth degree polynomial, which is not right. And so p of x is divided by x minus d. The remainder will be 0. So p of, oh, I'm sorry, here I made a mistake. That is problem number, so A is the right answer because I thought that it is p of negative b here, right? So it is not p of negative b. So in this problem, this is not true. So these all the remaining things are true. We need to pick out the which is not true, right? So the option is A. Right. Find all the roots of this polynomial. We know that this polynomial is the highest degree is 4. So it will have 4 values here, right? So this is your P, this is your Q. So what are the factors of 6? It is 1, 2, 3 and 6, right? Next, this is your P and Q is 1. So what are your rational zeros now? 1 divided P over Q is 1, 2, 3, 6 divided by 1. So what we do now? It is maybe plus or minus 1, plus or minus 2. Remember this method which I explained to you already, and you can watch the video in summative assessment number 2. Okay, so these all are your possible values of the given polynomial. So what we do is we try with these values first by using synthetic division. So let me write the coefficients first. 1, negative 3, negative 1, 9, negative 6. Okay, first let me try with 1. So bring down this 1, 1, negative 3 plus 1, that is negative 2. So it is negative 2, negative 3, negative 3 times 1, negative 3. So this is 6, 6 times 1, that is 6. So the remainder is 0. So one answer we got it as already 1. So it means either A or either this one, A or B, right? We have to pick among these two. So already what are the factors you have there? 1 already we got it. So the second factor is directly I will take from 2. I will check with the 2. So bring down this 1, that is 2, 0, 0, negative 3 and negative 6, right? So we got another value here. So this is x to the 4th exponent, this is x cube, this is x square, right? So that is x square, x and the number. So x square minus 3 should be 0. So add 3 on both sides. X square equals 3. X equals square root of plus or minus square root of 3. So which option is right? The first option. Okay, problem number 13 is a knowledge based question, I can say, because p of x is a third degree polynomial with the real coefficients. Which of the following could not be the roots of p of x? So if you observe the roots over here, this b, see, you got one root 5, another root is 1. The third root is only 2i. But remember that when 2i is the one root, definitely minus 2i should be the another root, because always remember that you will be getting if one root is a complex number, then another root should be its conjugate complex number. So this is wrong. And what about this one? 3, 5i and negative 5i. So this may be right, but wait for a minute. Yeah, just I want to make one correction here. So I thought that it is which of the following could not be the roots of p of x. So I thought that is which could be the roots of p of x. So the option B is right, because here we will be getting 4 roots, right? So but the given degree is third degree, so the option B is right. This may be the answer, this may be the correct one, or this may be the right one, right? Because we got 2 conjugate complex numbers here, 2 conjugate rational numbers here, but here we are getting 4 different values, which is not right. So for the problem number 13, the option B is right. Yeah, problem number 14. First, let us find out your rational zeros here. This is your p. The coefficient is 1 here. So factors of p will be, it's 1, 2, 4, 5, 10, 20, right? And what is your q? Q is 1. So p divided by q is 1, 2, 4, 5, 10, 20 divided by 1. So it may be plus or minus 1, plus or minus 2, plus or minus 4, it is plus or minus 5, plus or minus 10, plus or minus 20. Okay, now we use the synthetic division. So these all are your possible values. So among these values, we have to pick which one is the right one for the given polynomial, right? So coefficient is 1, negative 1, negative 21, 1 and 20. So let me try with the positive 1 here. 1, this is 0, 0, negative 21, negative 21, negative 20. So negative 20 times 1 is negative 20. So the answer is 0. So this is working for me. The second one, okay, you can try with the 2. I think the 2 doesn't work for me, because I should get 20 here, means I should get 10 here, right? So 2 doesn't work, 4 doesn't work for me. Let me try with 5. That is 1, 5. So 5 times 5 is 25. 25 minus 21 is 4. 4 times 5 is 20. Alright. So another value is this one. So we got 1 here, we got 5 here. Sorry, yeah, 1, 5. So this is your x to the 4th power. This is x cube. This is x square, right? This is x and this is constant. So what is your quadratic expression? X square plus 5x plus 4. Yeah, this one easily you can do it. So find the factors of 4 which gives you 5. That is 4 and 1. So it is x minus 4. Sorry, x plus 4 and x plus 1 equal each one to 0. So x equals negative 4, x equals negative 1. So what are the other two values we got it? X equals 1 and x equals 5. So the four values will be x equals negative 1, positive 1, negative 4 and positive 5. These are the four values for the given polynomial. Okay. Yeah, students, I think I have to stop here because it is becoming very long video. So I will explain the remaining problems from 15 to 34 in the next video. Okay, thank you.